go to friction right now, but first, just to recap then, the normal force is the force of the second surface pushing back on the first surface as a result of the first surface putting some force. Okay? Sometimes equal to Fg, but not always. And so we can't say that. But always, always, always perpendicular to the surfaces in contact. Okay? So that's the normal force. Then friction. Friction is a capital F and for some reason with a small fr. Okay? And friction is really like a surface's protest to an object trying to move over it. So if I push an object in some direction like this, friction will always oppose it. So friction always opposes motion or the desired direction of motion. Opposes motion or desired direction of motion. And what I mean by that desired direction of motion is sometimes the object isn't moving, but it wants to, but friction won't let it. So imagine you have a ramp with a box on the ramp. You should be able to imagine that if this ramp is really slippery or steep enough that the box would move down the ramp. If the box isn't moving down the ramp, because it wants to, everything always wants to move to its lowest possible location, and so if it isn't moving down the ramp, it must be because friction is acting up the ramp to prevent it. So it's not moving, but friction is still acting on it, and it's opposing the desired direction of motion. Okay, so friction always opposes motion or the desired direction of motion. A second important thing about friction is that all surfaces have some friction. All surfaces have some friction. Now we can polish the surface, we can Zamboni the surface, it's still going to have a little bit of friction. We can't get rid of friction completely. Obviously, the smoother, the more polished the surface, the less friction there is. But there are companies in the world that spend zillions and billions of dollars trying to get materials that have no frictions. One of those companies is companies that make roller coasters, because the less friction a roller coaster has, the longer the ride and the faster the speed, and therefore the more money the company would make because more people would come to go on that ride. Okay, so all surfaces have some friction. And how much friction an object experiences is directly connected to how closely together the two surfaces are, how much they're pushed together. So imagine that you're sitting on a toboggan and someone's pulling you across the snow. And or maybe you're pulling a little kid, and it moves really quite easily. But if I put another person in this toboggan, which causes the Fg to be bigger and the Fn to be bigger, now the two surfaces are squished closer together.